Okay, so we have to find the coupling coefficient and the energy stored in the inductors at T1. So we're given the angular frequency, which is 4 radians per second. V will be 60 phasor 30 degrees. Let's get the impedance value. So resistor will just be 10 ohms. The inductor will be 20J. The other inductor will be 16J. The mutual inductance will be 10J. And the capacitance will be minus 4J. Okay, and then let's get the mutual inductance value. So positive faces the red dot, negative faces the other way. Same goes for here. Positive red dot, negative other way. So let's have mesh currents here, I1 and then I2. So value for this will be the mutual inductance times the current that's entering this port, which will be I1. And then for this one, it's going to be 10J times the current entering this port, which will be I2. Okay, so first thing, we have to find the coupling coefficient, which is pretty easy. It's the mutual inductance all over the square root of L1 times L2, so it's 2.5 all over the square root of 5 times 4, which is 0.56, and it's unitless. So now let's find I1 and I2. So mesh I1. So it's minus 60 phasor 30 degrees plus 10 I1 plus 20 I1J plus 10J I2. Okay, so now for mesh 2, it's 16J I2 plus 10J I1 minus 4J I2. So 10J I1 plus 12J I2, that equals 0. Now let's bring the 12J to the other side. This and this cancels each other out, so it's 10. So let's isolate for I1. So it's minus 1.2 I2. We'll plug that into here. So minus 60 phasor 30. I'm going to bring that to the other side. So we just have 10 plus 20J I1. And recall I1 is minus 1.2 I2 plus 20. I think this was this I2. Yeah, this was I1. Sorry. Okay. Plus 10 J I2. And then we bring the 60 to the other side, so it's equal to 60 phasor 30. Okay, so let's FOIL all of this into here. So that's minus 12 I2 minus 24J I2 plus 10J I2 is equal to 60 phasor 30. So what else can we do? We can add these two together. That's minus 12 I2 minus 14J I2 is equal to 60 phasor 30. So let's factor the I2 out. So now we just need to get this in phasor format. So it's going to be 18.439 phasor. Let me quickly calculate the phasor degree. And you're going to get 49.398 degrees. But double check this on the Cartesian plane because 49.839 degrees is like somewhere up here. But minus 12, minus 14 that's like somewhere down here. So we will have to either add 180 or subtract 180 to take care of this degree. So I'm gonna subtract by 180, and I'm gonna get minus 130.61 degrees. That's what I'm gonna work with, and that's equal to 60 phasor 30. So I2 will be 60 phasor 30 all over 18.439 phasor minus 130.61, and I2 will be equal to 3.2539. So this divided by this, then we subtract these two values. So we phasor 30 minus 130. So that's 160.61 degrees, and this is in amperes. I1 is pretty much minus 1.2 of that value. So it's minus 3.905 phasor 160.68. And then I'm going to get rid of this negative here, and I'm going to distribute that negative into the phasor. So we have to subtract by 180. So that gives you minus 19.4. This is in amperes. Now get everything in time domain. So it's 3.2529 cos WT plus 160.61. And then for I1, it's 3.905 cos WT minus 19.4. Now W recall was 4. And so pretty much what they want is they want the energy in the inductors when T was 1. So T will be 1 here. But don't start adding them yet, because this is in radians, and this is in phase, and this is in degrees, and so is these two. So pretty much convert one of them to the other. So we'll convert our radians to degrees. So 4 radians, that's how many degrees is that? Let me double check. That's 229.18 degrees plus 160.61. And same goes for the other one. 229.18 minus 19.4. Okay, so 3.905. 3.2529, and you get the following answers. For I2, you should get 2.824 amps, and for I1, you should get minus 3.389 amps. Now, the formula for energy is pretty much 1 over 2, the first inductance value times I1 squared, plus the second inductance value times I2 squared, plus the mutual inductance times I1 times I2. So you just plug everything inside here. The 1 over 2, it was 5 henries. And I1 is minus 3.389 squared plus 1 over 2. The other one was how many? 4 henries. Then 2.824 squared plus other 2.5 henries times minus 3.389 times 2.824, and this should give you 20.73 joules.